Good morning, my dears. My name is Dr. Pathan Hussain Basha, working as an assistant professor in the Department of CSE. Today, I delivered the one lecture on Automata theory and compiler design. This course is there in the third year, second semester. Right now, we are discussing in this session mainly focus on the uh, defining the DFA, and if you are learning the DFA, then it will comes the learning outcome, construct the finite automation. And then next we are mainly focus on this session, finite automata with DFA and NFA. These are the concepts we are learning in the today's session. Now today we are discussing about the automata theory. So here, the automata theory is also called as a theory of competition. In generally, we call it as a automata theory is also called as a theory of competition. So here is nothing but competition is nothing but in generally we call it as a process. It means that if you are giving the any input to the particular process, some of the work is done. After that, it will produce the output. In generally, in the process, we are giving the some input, and it will produce the output. In between the input to output, there is a some process is there. So that's why this process is also we call it as a abstract machine, and also we call it as a model. It means that if you are giving the some input to the particular machine, it will produce the output. It means that what will happen in the abstract machine we have to discuss. So, for example, here I am taking the one example, that is switch. Here I am taking the one example, that is switch. So here generally on the switch machine there is on and off operations are there on that. Okay, so on the switch on and off operations are there. To perform the some push operation on the particular switch, it will gain the off. Then we perform the sum of the operation on switch, then off to on. Like that only here some of the operations may be performed on particular machine. In this way we have to discuss this one next. So here automata. So in generally automata is a machine or else model. On that particular automata, some of the different operations current representations are there. So representation of the automata in different ways. So like that, so here I am taking the symbols. Here I am taking the symbols. In generally, we consider as a 0, 1, 2, 3, and so on. These are the some symbols. At the same time, here I am taking the only numerical numbers. But, and also I am taking that alphabet, it means characters. Characters also can be taken as a symbols, and numericals also can be taken as a symbols. Then next, we have to taking as a alphabets. The alphabets can be represented as a symbol sigma. It means that alphabet is nothing but a collection of symbols. So alphabet can be represented as in a letter sigma. The sigma is nothing but the collection of the symbols. It means that the sigma can be write as a like this 0, 1, 2, 3, and so on. This is in binary way, binary representation. Okay. The sigma also can be represented as A, B, C, D, and so on. Okay. So whatever the symbols are there, those symbols are placed in a set format that is called as a sigma. That is nothing but the alphabet. So here I am taking also the string. String. String is nothing but collection of symbols over alphabet. Is nothing but, so here I am taking that 0 and 1. Okay, so the 0 and 1 is the alphabets. These alphabets can be represented in the string format like that: 0 1 double 0 0 1 1 0 double 1, like that, and so on. So whatever the elements we are taking, those elements can be represented in the string format. It means that like this. So next, language. Language. The language can be denoted by the L. Okay, it means that collection or else set of strings over the alphabet. It means that the L is equal to A comma B comma A B or else A B A and so on. Or else if I am taking the alphabets as a 0 comma 1, the 0 comma alphabets can be written as a 0 1 1 0 1 0 1 and so on. So these are the basic concepts of discussing in the automata. It means that automata is a model or else it is a machine. It can be represented in the different representations like symbols. We can consider as 0, 1, 2, 3, 4 and ABC are a symbols. Like that only here I am writing the alphabets. Alphabets can be represented as a sigma, is nothing but the collection of symbols. Those can be write like this. So after that, we can discussing about the strings. The string is nothing but the collection of symbols over the alphabets. This can be represented as a 0 and 1s, and this can be as in string format. Like that only language. Language L is a collection of or else a set of strings over the alphabet. So those can be write as a like this. Now we are focusing on the finite automata. Okay. The finite automata can be represented in five tuples, in a five tuples way. Okay. So for example, here I am taking as a M is a finite automata. In that I am writing that capital Q, sigma, delta, Q naught, and F. If a machine can be represented in a five tuples, that is nothing but the finite automata. So here, where where Q is nothing but set of states. So at the same time, sigma is nothing but is a set of alphabets. The next, delta is representation of the transition function, and Q naught is called as a initial state. F is a final state. So in the five tuples way, the final state automata can be represented. For better explanation, we have to draw the transition diagram here. Let us take transition diagram here. Let us take transition diagram. So this transaction diagram can be is there in the five tuple format or not? We have to check it once. Just here, Q is nothing but we are taking as a Q naught and Q1 as a states. Then next, here the alphabets are having that 0, comma 1. The next transaction function. Here the transaction function formula is Q into sigma is a Q. It means that Q naught is the initial state. We are taking as a zero transaction input symbol. Then we produce the next state as a Q1. So like that only. Q naught is represents here. Q naught initial state. Here the initial state and F it is represents the Q1 is a final state. In this way. Here the finite automata can be represented in the five tuple way. We consider M is equal to Q, sigma, delta, Q naught and F. These are the five tuple representation in finite automata, where Q is a set of states and sigma is a set of alphabets we consider. Delta is a transaction function, Q naught is the initial state and F is the final state. For representation of this one, let us take one example, that is transaction functions. So transaction diagram. Here transaction diagram we are taking as a Q naught is a state and Q1 is a state. So here the every initial state, every starting state is a initial state that can be represented as a arrow mark, and here the double circle is represented as a final state. Here the Q naught is a final state and Q1 is the initial state. So here what are the transaction inputs we are taking as 0 and 1. So those are the taking as a alphabet. Sigma 0, 1 is a alphabet. The next transaction function, here the transaction function calculation, Q into sigma is equal to Q. It means this Q is represented as a next state after calculation. Here the Q naught is the initial state and the next 0 transaction, then it produces that Q naught. It means a self transaction. Like that only here also writing that Q1 into 1, it produces that next state Q naught. Q naught is the initial state and 1 is a transaction function. Then next it produces the next state as a Q1. Then next Q naught is represents the initial state Q naught. F represents the Q1 final state. So like that only here we have the transaction table is also is there. Transaction table is also there. So the transaction table can be write like this only. So here 0, 1 is taking as a alphabets and the input signals. So whatever the states are there, those are writing here Q naught and Q1. So here Q naught is having that 0 is a self transaction. That's why it produces the next state Q naught. Q naught is a one transaction. It produces the next state as a Q1. So Q1 is having that 0 as a self transaction Q1 and Q1 is having the 1, it's a self transaction Q1. Like that only here we have to draw the transition table. Okay. A finite automata can be represented in the five tuples format, and based on the five tuples we have to draw the transition diagram and as well as the transition table. In this way we have to represent the finite automata. Based on that the finite automata can be represented in the two ways. So here the finite automata mission is having that two types of automatas are there. The first one is that finite automata without output, finite automata with output. It means if you are taking any finite automata mission, that will not produce the output. So it means the without output missions can be represented in three ways. That is DFA. It means deterministic finite automata. NFA. It means non-deterministic finite automata. and epsilon NFA, epsilon non-deterministic finite automata. These three machines can be produced without output in the finite automata machine. So here, with output machines are having that two types of representation. One is the Mori machine and second one is the Millet machine. Millimeter. So the finite automata can be represented in two ways. One is the without output and with output. So without output can be represented or else can be having the three types of machines. One is the deterministic finite automata, non-deterministic finite automata, epsilon NFA. So next finite automata can be represented as Mori machine and Milli machine. So in this session we are mainly focused on the deterministic finite automata. DFA, the states which contains more than one transition, one transition per given input. It means that if you are having the one state, the state at least having the one transition for a given input. That is the main rule of the deterministic finite automata. So here, based on that one, here we have to see the, let us see one example on this one. So here, based on this one, we have to take that Q naught is a initial state. At the same time, it is having that 0 as a self transaction input, and next Q1 to 1 transaction, it will produce the next state Q1. At the same time, Q1 is also having that 0 as a self transaction Q1, and if the Q1 is having the 1 transaction input transaction, it will goes to the Q naught. It means that whatever the alphabets are there in the given example, 0 and 1, those are having that 0 as a self transaction and 1 is having that Q1. So here Q1 is having that self transaction 0 and 1 is going to the Q naught. Like that, these two inputs are using in the each and every state. So that means that state which contains more than one transition for a given inputs like that. Okay. So based on this one, we have to draw the one table for this one 0 and 1, Q naught and Q1. Here Q naught is having the self transaction Q naught, and the Q naught is having the one transaction Q1, and Q1 is having the self transaction Q1. Q1 is having that one transaction, it will goes to the Q naught like that. This is the table and this is the diagram, and these are the alphabets we are using. Based on that one, we have to draw the DFA. The DFA can be represented in starts with, ends with, starts with, ends with, and length, divisibility. So in this way, the DFA can be represented as starts with, ends with, length, and divisibility. In the these are the four methods we are using the defining of the DFA, deterministic finite automata. Let us see one by one. First, we are focusing on the starts with. DFA starts with. Here we are taking the one example, construct DFA which accepts all the strings over the alphabet sigma 0 comma 1, which starts with 0. It means that the construct a DFA. First of all, we have to construct the DFA. In that, it accepts all the strings over the alphabet. What are the alphabets are there here? 0 comma 1. Those can be represented in the string format. This string can be accepted by the DFA. The condition is starts starts with 0. It means that whatever the alphabets we have, those alphabets can be written, those strings are accepted by the DFA, and it can be starts with the 0. It means the condition. So here I am taking the language. For solution purpose, here I am taking the language. Language L starts with 0. So here I am taking the first element that can be having that in the string format. After that, I have to write down 0, 0. That can be having that in string format. We are taking the alphabets in number of times. So 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1. So like that. Okay. So here I'm taking the string L is equal to, so L is having that infinite format, infinite state. That is having that infinite state. Based on the alphabets, we can create a number of strings for the particular DFA. That's why that is having that infinite state. So based on this one, I have to draw the transition diagram. Based on the DFA conditions along with the strings, here I have to write down the transaction diagram. So here we have only the one element as a string. So that's why we have to take two states. Why? Because here we have to take in only single element. A single element can be transferred from the only within the two states only. That's why Q naught is taking as an initial state and Q1 taking as a final state. So here the Q naught to Q1 transfers the input symbol 0. After that, we have to check next string. So here Q naught is having that 0 to Q1, it reaches. Then after that, it is having that self transaction 0, it will produce. So Q naught to 0 transaction, it will goes to the Q1. Here the Q1 is having that self transaction 0, it completes the string 2. Then next, we are focusing on this one. So Q naught to 0 transaction Q1, and after that here the 1 is there, here having that self transaction 1. So Q naught to 0, it reaches a Q1, and Q1 is having that 1 as a self transaction. The string is over. Then next here, the next 0, 0, 1 is the next string. So here starting state Q naught to 0, it goes to the Q1. Here 0 is the second uh, element, and it will having that self transaction, and next is 1. So here the 1 is having that input string, it will having that self transaction. Like that only here this one is completed. Then next here we are taking this string. So Q naught to Q1, it reaches 0, and next 1 and 0 is a self transaction. Like that only you have to create this one. For example, this is not follows the, here we have to take the two elements 0 and 1, but here the Q naught is having that only 0 transaction to the next state. So that's why another state we have to take in, that state is called as a Q pi. It means that from Q naught to 1 transaction to q pi, it means that this one is called as a dead state or else null state. So here we are taking that q pi is a dead state and null state. This one is having that self transactions 0 comma 1. So this one is follows the DFA rule. So that is DFA accepts all the strings. So it accepts all the strings over the alphabets 0 comma 1. So here the output having that q naught is having the 0 transaction to the q1, q1 is having that z1 transaction to the q pi. It follows that whatever the alphabets are there, those alphabets having that q naught state having the transactions 0 and 1. So here q1 is having that 0 and 1, those are having the self transaction. It is also follows the alphabets. Okay, q pi is also having the 0 comma 1. Okay, so based on this one we have to draw the transaction table. Transaction table. Okay, so 0 1 is taking as input symbols. The states are having that q naught and q1 is input symbols states. Okay, so q naught is the initial state with representation of arrow mark, and q1 is a final state that can be represented as a star mark. Okay, it indicates that we reach the final state. The arrow marks indicates that we have having the initial state. From initial state to 0 transaction, we reach the next state q1. Okay, so from q naught to the initial state 1 transaction, we will reach the q pi. So here Q1 is having that 0 as a transaction, it will reach the self transaction Q1, and as well as Q1 is having that 1 as a input transaction, it reaches the Q1. And again we have to take in also Q pi also. So it is having that self transactions Q pi. So Q pi is the initial state 0 as a self transaction Q now Q pi. 1 is having that in one is a transaction function, it teaches a self transaction q pi. Like that only, it means that it starts with a 0. If you are observing the this string, each and every string starts with a 0 only. Each and every string starts with the 0 only. That's why this one is called as a starts with a 0. So again we have to check it once. Starts with 0 1. Starts with 0 1. It means that construct DFA which accept all the strings all the strings over alphabet sigma is equal to 0 comma 1, which starts with 0 1. So based on this one we have to create a language. Okay, so first one is at 0 1. Okay, so whatever the elements are there, those elements 0 and 1, here the condition is starts with 0 1. So here I am taking the first 0 1, after that 0 1 0, and the next 0 1 0 1, 0 1 1 1, 0 1 0 1 1, and so on. Okay, so like that here I am creating the language. Based on this language I have to draw the DFA transition diagram. Transition diagram like that. So here in the first string having that two elements, it means that two let two input symbols are there. For that purpose, here I am taking that Q naught is a initial state and first 0 as a first input transaction to the Q1, and again Q1 is having that another state Q2. The Q2 is having that one is the uh, in input transaction to the Q2. It means that Q naught is having that initial state and Q2 is having that final state. In between the transaction 0 comma 1, the first string is over. Then next 0 1 0 1 from Q naught to Q1 0, Q1 to Q2 1. Then so here the another element is there, another alphabet is there 0, that is taking as a input symbol to the Q2 is a um, self transaction. Then next, this string is over. Then next, we are focusing on this one. So 0, 1. After that, again, 0 is there. And the next, here 1 is there. The 1 is taking as a self transaction. Why? Because from starting to the ending, so the string must be ends at the end statement only. So that's why Q2. So each and every string ends at the end of the state only. So here the 0 from Q0 to Q1 0, having the Q1 to Q2 one transaction 1. The next here again 1 1 is there. 1 1 is there. So 0 1 1 1. So this one is over. Then next 0 1 0 1 1. So like that only here transaction is there. So it is not follows the this diagram is not follows the DFA rule. Why? Because so here the elements are there 0 comma 1. Here only the Q naught here are taking that dummy state or else dead state 1. Q naught to 1 is having that Q pi. Then next here also taking the 1 is the output transaction, 0 is the input transaction. So here we are giving the 0 is the input transaction to the Q pi. Then it will be having the self transaction 0 comma 1. Like that only here Q naught to 1 transaction it reaches the Q pi. So Q1 having that 0 transaction reaches the Q pi. So Q pi is also having the self transaction 0 comma 1. So in this way the given string is having that follows the DFA rule. So here our condition is starts with 0 1. Each and every string starts with 0 1 only. If you are observing that every string starts with the 0 1 along with the alphabets 0 comma 1. So in this only we have taken the 0 and 1s only. These alphabets having accept all the strings, whatever the string alphabet strings are there, those alphabet strings are accepting the DFA. It means the DFA rules having that each and every states how many alphabets are there, those alphabets are transaction from the each and every state. Based on that one, Q naught is having that 0 transaction and 1 transaction. Q1 is also having that 1 transaction, 0 transaction. Q2 is also having the self transaction 0 comma 1. Like that only here we have to follow the whatever the rules are there, those rules starts with the 0 1 1 and along with the alphabets and all the strings are accepting the DFA. We are creating the transaction diagram. Based on this one, we have to create the transition table also. Transition table. So here I am taking the transition table like this 0 comma 1 as a alphabets and the next states. Here I am taking the states Q naught, Q1, Q2 and Q pi. So here we have the 4 states are there. The 4 states are represented like this. So in this uh, starting state is representation as arrow marker Q naught and Q pi, sorry, Q2 is having that final state. So here Q naught is having the 0 transaction, it will reaches the Q1 state. So again Q naught is having that 1 transaction, it reaches the it reaches the Q pi. So here again, Q1 is having that one transaction to the Q2, the zero transaction having that Q pi. So here Q2 is having that self transaction 0 comma 1s. That's why we have to write down Q2 and Q2. So here Q pi is having the self transaction Q pi and Q pi. So in this way we have to represent the DFA diagram in the transaction given strings, transition diagram and transition table like this only. Okay. The next we move on ends with the 0. Construct DFA which accept all the strings over the alphabet 0 comma 1 which ends with 0. It means that we are taking a language, the language is having that infinite state. Okay. So here we are taking the alphabet 0 comma 1. The condition is ends with the 0. It means that starting state taking as a 0, and then next we have taking 1 0, 1 1 0, 0 1 0, 0 1 1 0, 1 0 1 0. So here I am taking the string. Those string is accepting by the DFA or not. So let us check through the transition diagram. To transition diagram, the given string is accepting the DFA or not. Just here, first string is having that only one input symbol 0. So that's why here I am taking that Q naught is a starting state. From Q naught to Q1, it will reach the transaction 0. Okay. From Q naught is the initial state, 0 transaction, it reaches the Q1. It means this string is over. Then next, we are focusing on the 1 0. It means that Q1 is having that self transaction 1, and the next element 0 transaction, it reaches the Q1. It means the final state. Again here, this one is over. Again we have focusing on this one. One is a transaction element, and next again one is the input transition element which reaches the Q naught, and next we are focusing on the 0 Q naught to 0 transaction, it reaches the Q1. This one is also over. So here the 0 Q naught to 0, it will reaches the Q1. So here the again here 1 is there. So for 1, Q1 is having that self transaction 1, and it reaches the 0 also, Q1 and 0 and 0. So 1 0, it reaches Q naught to 0, it reaches the Q1. Here the 1 0 is there. That's why Q1 is having that one representation, self representation 1, and again it represents a 0 having the self representation 1 0. So like that only here also this one is over. And next you are focusing on the 0 double 1 0. So here also 0 1 1 0. This one is over. The next 1 0 1 0. This one is also over. So 1, sorry, starting with the 0 and 1 1 0 0. So like this. So here the condition is having that DFA, the state must be having that whatever the input alphabets are there, those alphabets are transition from the given state. So Q naught is having that initial state. This one is having the zero transaction to the Q1, and Q naught is having that zero transaction to the self transaction 1 along with the Q naught. So Q1 is having that state that is having that 1 as a self transition and 0 is a self transition. So based on this DFA condition, the given string is accepting the all the values of this one. So we have to draw the transition table. 0 and 1. So here I am taking the Q naught and Q1. So Q1 is having the final state. This one is the initial state. So Q naught to 0 having that Q1 is the next state. So Q1 is having the self transaction 1. We are getting that Q naught. So Q1 is having the self transaction Q1 and Q1. So this is the transition table for the ends with the 0. Like that only we are seeing another one. Ends with 0, 1. Construct DFA which accept all the strings over the alphabet sigma 0 comma 1 which ends with 0 comma 1. Based on this condition we have to take in the infinite state, infinite string. So here starting 0 comma 1 and again ends with. So here the given string is having that infinite state. In the first string is having 0, 1. It means the alphabets having the 0, 1 only. So based on this one, we have to write down the transition diagram. So here, two input symbols are there, 0 comma 1. For that purpose, here I am taking that Q naught is the initial state. It will go through the 0 transaction. It reaches the Q1 state. Again, Q1 is having that one transaction, it reaches the Q2 state. That is the final state. It means that starting string 0 comma 1 is there. It starts from the Q0 to the 0 transaction Q1 and it reaches the Q1 to the 1 transaction to the Q2. Like that only this string is over. The next we are focusing on the this string 101 is there. So here the Q0 is having the starting states that starts with the 1. 101. The string is over. One is having the self transaction. The next Q0 to Q1 reaches the 0 transaction. Q1 to the Q2 it reaches the 1 transaction. The next here 0 comma 0. So here the Q0 is having that initial state. It reaches the 0 to Q1. Again here the another one is there. It represents the 0. It means that Q1 is having the 0 transaction and the next it reaches the 1 to the Q2. So this one is over. Then next we are focusing on this thing 1 1 is having that self transaction, then again 0 and next one is the 1 transaction. This one is over. The next 1 0 0 1 1 0 0 1 is over. 1 0 0 1. the next here 1 1 1 1, the next 0, the next 0 transaction, and after that 1 transaction. Okay, so like that only. But unfortunately here the Q naught is having to follow the DFA rule. That is the input symbols whatever there, those are having that transaction. 0 comma 1 is having that Q naught transaction. So here Q1 is also having that 0 transaction and 1 transaction. But Q2 is does not having that DFA rule. It not having that 0 and 1 transaction. That's why here we have to write down the 0 comma 1 transaction. Okay, the self transaction. Why? Because ends with the 0 comma 1 only. Otherwise we have to try. This one is taking as a pi also stated. Each and every uh, alphabets or strings ends with the in a end statement only. End state. That's why here I am writing the 0 comma 1. So based on this one, we have to write the transition table. So here the Q naught is having that initial state. That's why that can be represented as arrow mark, and Q2 having that final state that can be represented as a star mark. So here the Q naught is having the 0 transaction. It reaches the Q1 state. Q naught is having that 1 transaction. It reaches the Q naught state. So here Q1 is having that 0 transaction. It reaches the Q1. Q1 is having the 1 transaction. It reaches to the Q2. So Q2 is also having that self transaction Q2 to Q2. So like this only, we have two representation of the DFA in starts with and ends with. Okay. Thank you.